by Professor Kristen Grauman. Kristen is a faculty member at UT Austin and currently also a research scientist at Facebook AI Research. Personally, one of the things that has always stood out to both Devi and me about Kristen's work is a certain level of attention to detail. And there's, we all write these papers that close to the deadline is often some of the times when we get our main result. But for some reason, every single paper that at least I've read of Kristen's, it never stops at the main result. There's always like, if there's an interesting question to be asked, it is answered. And there's a certain level of sort of well preparation that always leads to that. So we're really happy to have Kristen. And today she'll be talking about tips for preparing a clear talk.
Okay, great. Thanks, Dhruv. And I hope I can live up to that explanation or prep. So hi, everybody. I am glad to be here. And Devi and Dhruv, thanks for making this event. What a great idea to gather up various advice at different levels and things. I think it's really nice. So, okay, so when Devi reached out to me about this, kind of related to what Dhruv just said, she suggested, you could talk about, to me, she said you could talk about something about being reliable or following through or staying organized. And I do think of myself as an organized person, and I'm really honored that Devi thought I have the quality. But then when I thought about trying to translate my system for staying organized, I realized it's like really high tech. It's here, right? So this is not something that I think will be something to talk about and share with you. This is like, my scattered non-electronic to-dos and organization. So that's not this talk, but offline, if you want to hear about this system, I'll tell you all about it. Okay. So instead, I'm going to talk about just some tips about preparing a clear talk. Okay. So things that I think work as an audience member, things I strive for as a talk creator. And so naturally, this leads to a disclaimer. I don't always give a good talk, don't always give a clear talk, don't always prepare a clear talk, but I want to tell you about the things that I'm shooting for or things I tend to promote for my students when I'm looking at talks and iterating with them. Okay? So that's what this is about. And so I've arranged, some guidelines or some topics that I'll touch on and in a very casual way, just tell you things that come to mind of when I try to organize my thoughts about it. So I'm going to talk about things like thinking about what the audience composition is, being very clear and direct about your points, being concise when we can, giving credit when it's due, and thinking about that part of the talk that involves questions and answers, a little bit of overview of delivery tips that I always like to keep in mind, and talk about the details of what I value in some very clear slides. Okay, so that's where I'm headed. And so let's start with the first one of considering the audience in the event. And by the way, everything I'm saying, many of it may be things one already knows and does, but hopefully I'll suggest one thing here or there that, by making it explicit helps us think about how we prepare these things a little bit more. So anyway, considering the audience in the event, you know that your talk could be targeted to this very crowd, but it can be different things too, right? And they'll vary. So are you preparing a talk to give to your group meeting so that you can get some in-depth feedback? Are you giving the talk at CVPR? Is it a job talk where you're going to be talking to a broad audience outside of computer vision, maybe within CS or maybe even broader than this? Is it an interdisciplinary audience? Or are you doing some outreach event where you're going to talk to children or school kids that might pursue computer science someday later? Is it formal? Is it casual? So all of these things, as you I'm sure can imagine, will dictate the content level that we need to prepare. And so the kind of parameters that you think about as a function of audience would be the degree of detail, of course, and with the prior that the more specialized the audience, the more detail becomes relevant. Also the degree of jargon, which is correlated with that one, right? But especially when we think about wider audiences, like the job talk, where, a talk that's A+ for a computer vision audience could have a very hard time for a general CS audience because there's our own language, grammar, and expectation. And I mean literally the language, but I also mean, assumptions we make easily about what it means to set up experiments in our field, right? And that has to be things that we explain once we talk to broader audiences. Depth versus breadth, this relates to the degree of detail, but also I'm thinking of this in terms of if you're preparing a talk for a job talk, say, academic, industry, whatever it is, you may need to make judgment calls about what will be valued in terms of showing your technical depth on something specific, maybe the case, or showing some track record and some arc of progress over your contributions that can be linked together. And that leads to, different talks. Okay, so that was kind of think about the audience. Probably that's the first thing one does when sitting down to create a talk. The second main tip I'll prioritize is don't bury the lead. So what this means is essentially being direct is, for me, as an audience member, quite valued. And so to the point that I would expect in most talks to have some format like this, where there's some slide that states the problem in simple, short terms, and there's some slide that nearly after that is stating your idea. Okay? And of course, we see this format a lot in the CVPR talks and the posters, but I think this is crucial in the spirit of don't bury the lead to come right in and motivate, set up, here's the problem, here's the idea. And the our idea part being very crucial, right? If you want to make sure the contribution you're trying to express has no room for doubt, right? We just need to spell it out, okay? The other thing that comes to mind on this theme for me is the value in, as a speaker, reiterating and rephrasing a point. Okay, so suppose there is some main idea, some thesis of your talk, then it'll be stated up front. But then, of course, the idea for the remainder is that this carries through, and we get reminded about it as an audience member. And to be specific, I think great places to do this tend to be when you revisit, maybe you have an organization of the talk, the outline where you're coming through, you've shown example A, you've shown example B, and this is great times to rephrase that whole message from the front of the talk that says the thing you're trying to really argue for or explore, okay? And then that includes with results, showing things that support the theme and then telling us in very direct terms why that just supported the theme. Okay. Along these lines too, I think verbally, things I'm cued into and might suggest if working with someone on talk is to give salient verbal markers that this is even happening, right? So everything you say in the talk hopefully is important, but some of the things are more important than others. And it's great, I think, as a listener, when there's salient verbal markers that say, okay, the important thing to notice is blah. Or, I really want to stress that blah. And, that way you give some highs and lows that really help, hopefully, get the message the way you wanted it. And finally, on this theme, I think about punchlines. So I use this term to mean kind of the one-liner that's the takeaway from a result. So often our talks, at least they see CVPR-style talks, there's the format of intro, problem statement, what I want to do, the approach, some technical detail, and then results, say, much like a paper. And in the results section, both in the paper and the talk, it's so valuable, I think, to have that one-liner, and don't leave it hanging, right? So you've shown the precision recall curve or something more intricate about what you needed to show, and then let's spell out in a simple way what it meant. So I'm always looking for that in slides and in talks. So I've talked about knowing the audience, thinking about that in terms of grading content. I've talked about being direct and don't bury the lead. The other thing I'll say is being concise, I think, has a large role for a clear talk for me as an audience member. So you may have seen this quote, right? So I didn't have time to write a short letter, so I wrote a long one instead. This so much applies to talks, in my opinion. Preparation for a long talk tends to be easier than preparation for a short talk, right? And if you are a spotlight author, you know this really well, right? 4 minutes, super hard to be, get the right stuff in. And so being concise and being forced to make those judgment calls of what to say or not say is hard, but also necessary to have success at the end for the clarity. So, things along these lines that I think about, one is that it's quite useful to prep, I'm going to call it like the concept bullets, right? So you have bullets on your slides, maybe, fine, but I'm talking about more, you've got some visuals prepared for your presentation, and then the prep, for me, especially in a longer talk, would amount to thinking about the flow of information as some bullets, pretty much per slide. And, in a longer talk, you don't need a verbatim script about what that's going to be. Let's hope, we can usually avoid. A shorter one, maybe you do. But especially in a longer talk, then thinking through, okay, I'm going to make ABC, and then I'll let it unfold in the words I use in that moment. That's fine. But it relates to concision, or being concise, because, this is, if the bullets are there in one's mind, then you're eliminating the extraneous things around it that could kind of derail from what you're really getting to, okay? And I realized that on the last slide, I suggested let's be repetitive and redundant and reinforce concepts, and here I'm saying being concise, so there's a balance between these things. What else on being concise? Well, breathe. I mean, yeah, I know you didn't come here to learn that you should breathe while giving a talk, but it's true that it's easy to forget, right, to breathe quite enough. And so part of being concise goes in hand with having fewer words to say something, and also having pauses, right? So sometimes we feel at the first it might feel unnatural to stop and pause, but I feel like as a listener, it's so valuable for me to digest, right? And so that's something easy we can do and sprinkle in. Short text phrases, so once you talk about slides, I would highly value clarity in terms of very little text on a slide. In fact, the talk I'm showing you now has, the more text than any talk I think I've given, because it's become more like points rather than, object detection or something else. But very few text, as we know, is pretty good rule of thumb for this. And just keeping in mind that not every detail needs to surface. And here I'm talking more about content. Whether it's a CVPR talk or something else, the paper is there. And part of the talk's role is to get your audience interested and understand the direction you're exploring such that they will check out the paper later. And so there's judgment calls, of course, to make about things that are there or not there. And sometimes it feels really hard as an author because it all feels so important, right? But that's where your peers, your advisor, whomever you're working with on a talk can help make these judgment calls. Okay. All right, so being concise was last. Now let me mention brief things about giving credit. So, I think first ones are no-brainers. So painting the big picture of the literature for context. This is, in a great paper, this is usually done very well in an introduction of the paper. In a great talk, this will be there too, especially the more technical the talk is. There'll be one level of that. The more job talk and broad it is, it'll be, even higher level. So we know we need to do this. There's also the chance to present related work with some synthesis, right? Both in the paper and in the talk, where I would like to think about the space of related work that's nearest and then cluster it, right? We certainly don't want a laundry list of everything that's been published or the set you think one thinks is most important, but we do want that work you've done to synthesis into, okay, there's methods that do A, there's methods that do B, and here I am doing C, and here's where it connects, right? And that's, this is both appropriate scholarly thing to do. It also adds a lot of credibility for what you're presenting, right, to show that firm context. The last item I was going to mention here is more low level, which is a suggestion I have, which is whenever you borrow slides, which is something quite common in our community and good to not reinvent the wheel and so on. I think it's quite important actually to attribute credit, right? So things I like to do is on the slide that if I were to borrow a slide, you can write the name of the author of the slide on each slide. I always make a point of this in my grad class because especially if I'm going to go post slides online for my course, and they belong to someone else, if the student has permission to use it, that's great. But we want to propagate that credit, right? Because I don't know about you, but you've probably found a slide that you created online that's got, it's attributed somewhere else or there's none. And, we should give credit for the creation. And so I always ask my students to do that, especially in a course environment. Okay. All right, so what's this? This is an abyss. And I think for many of us, especially, when you're starting out or giving some of your first talks, the Q&A seems so scary, right? Because we can't super prepare for it, right? I'm talking about preparing a clear talk. Well, the Q&A, it could be anything technically, right? You don't know what questions are going to come your way. This is the unknown unknowns. So I was trying to think of, what advice I have, what process I would go through in preparation. So of course we can try and anticipate those most likely questions, okay, and prepare for those. And if they're so likely that they just belong in the talk, go ahead and squeeze it in the talk. But otherwise, it's good to know and have formulated maybe even clusters of questions such that you have topics that you could bring to each. Here's a more practical tip that, maybe personal taste, but I'd say pretty much avoid skipping to backup slides unless it's really, really needed. Okay, I feel, especially in short form at talks here, if there's a question that makes you think of a slide you have in the background, it's fine that it's there, but you probably don't need to go fetch it. It would be enough to just answer a question rather than pull up the visual. I think that the reason why is it distracts, it adds time, and we usually don't actually need to see the figure at that moment. Along those lines, I think sometimes it's better to defer a question. This more relates to longer talks with an audience that might be interjecting a question. Maybe it's your committee, your thesis committee, or maybe it's just the seminar and someone's asking, and many of the times answering it right there is just right. But sometimes it's just fine to defer, right? Because maybe 2 slides later, you're gonna go in really good, organized way about this. And so it's not rude or anything in some cases to be like, you know what, I'm gonna get to that. Just give me a minute and let me know if I don't cover it by the end of the talk, something like this. And then with answering questions, I think this can be difficult, but just answer it and then stop. Sometimes it's easy to say it a couple times more. Here's a place where I probably would not be redundant. And then something that we all can do is once you've given a talk about work with other people, it's great to come back and share the feedback you got. Like what were the questions and what were the comments, and that will certainly improve the talk the next time. Okay. Now, I have a couple, 2 main items. This next one, delivery tips. So I've talked a lot about different rules of thumb that I would follow for creating the talk in terms of content, and a little bit about the slides. Now let me talk a little bit about delivery. So it goes without saying, but here I am saying, like, we have to practice, right, and get feedback. So for talks with a high time pressure, there's no other way, and even for a longer talk, getting that practice in is so valuable. Another thing that we might not think always about is that first slide. What are you going to say? Because that first slide is just your name and a title, and you can read the title, you can read the author names. That's maybe the level 0 version. Maybe the level 1 version is a little bit paraphrased of that. So, if the session chair just said it, you're not like saying it again. And then maybe the level 2 could be something more conversational or something, exciting to get us into the moment. Be loud enough. So I've found when I watch students give talks, like volume does so much for confidence, implied confidence and excitement, right? So I think this adds so much, and it's, as long as we remember to do it, including, I would say, practice that way, which one doesn't always do. If you're practicing alone in your room, it feels crazy to be loud, but there is something to it. The way you've practiced it translates to the way you give it. Use pauses, I already mentioned this. Flow, so when I think about delivery of a talk, I mentioned having bullets in mind. Also, when I think about a slide, I think it's great to have explicitly thought out, and especially in key moments, where did we just come from and get into the slide, and then where am I going out to? And if you use speaker notes, sometimes I would even mark those in the ones I really don't want to miss so that the audience stays with me, right, through the chain of thought. Qualitative examples, I see this a lot in presentations. Like, we have all these great visuals in computer vision. You put an array of image examples, and again, that might be the level 0 version, but the level 1 version could, first of all, make one of them bigger maybe, but also like say something concrete about 1 or 2. Because as an audience, if we're lazy, we just stare, but if you're active and tell us, see here this, see here that, then it comes more alive. Okay, manage your time. I always try to keep my stopwatch and remember to get it started so that I know where I am. If you're skipping something, then skip it. So by this, I mean, you've probably seen cases where, it happens, you run out of time, but then slides start flashing by, and then the author spends time saying how they're gonna skip it, but they don't really skip it. And so I would just like a clear yes or no, like, is it happening or not? And so if you say, I'm gonna skip this amount of time, but here and this and this and this, and so that's hard because it takes time, but you still don't really understand what was said. So that's kind of a personal taste tip. Here's one that might sound weird, but think about where you want to stand. Test the room. So if you can test the room before an important talk, feels good to be prepared. But thinking about where you stand, sometimes you come to give a seminar somewhere, and the physical configuration is different, and sometimes there's choice, right? And so thinking about that in advance, I've given talks where I realized, why did I stand there, like behind some table that I didn't need to? So actually, then I regret it. So if you think about it in advance, it's good. Check your laptop. And nerves. I mean, everyone gets nervous, and sometimes I think about this approximate quote from my PhD advisor, Trevor, which was something to the effect of, if you're nervous, it just means you care. So if you think about that, then it turns it as if this is not bad, it's just that I'm wanting to do it right. Okay. All right, so the final thing I was going to touch on, and I know I have just a short bit left for time, is detail-oriented, which is, I guess, if you've worked with me, one of my students would tell you, like, kind of obsessive about slide perfection. I'm not saying I always achieve slide perfection, but I know it when I see it. And so these are the kind of tips that I always suggest, like animation, big block of stuff. I don't know where to look, but if you animate in a careful, thoughtful way, I'd know what to do. And I mean, if you've seen slides by Devi and Dhruv, you know exactly what I'm talking about. Font size, 28 plus, let's say. Simplest visual possible to make the point. Okay, again, reduce till the essence is there, and so the audience doesn't have to work hard to get it. But here's some low-level stuff, like consistency. I can't stand it if there's a capital word and then a lowercase word and then a capital word, or if sometimes it's capital and sometimes it's not, or if the alignment is like just like, you know, a couple millimeters wrong, like it's just distracting. So for your audience mental load, if we can keep it precise, I think it's helpful. Along those lines, jitter, you don't want to move stuff around in consecutive lines, try to use one line. Color is a good tool for clarity. Here's one. Sometimes people write scripts, and like the script's not going to show except if you've got your slides in a view where they do show, and a lot of times you'll see the slide says, hi, my name is John. I'm going to talk about this, and that's fine, but delete it before you give the talk. And another personal taste one, I feel like the last slide with just a thank you is like a wasted opportunity because there's no content in that thank you. You can say thank you, but you could put your conclusions there or the link to your page or your pictures of your collaborators, whatever it's going to be, and then people stare at it while they ask you questions and they get a message. Okay, so that's it for me, and thanks for your attention.
Thank you, Kristen. We have time for maybe one question.
Hi, thank you for the great talk. One of the things our advisors say is put a lot of time into preparing talks, and like I think they have a formula for which is sort of proportional to the size of the audience. What do you think is a good sort of preparation time for a good talk?
Do you mean bigger audience, more time kind of thing?
Or like, what do you, like, how much time do you think?
How long does it take to make a talk?
Yeah.
It takes so long. I mean, the size of audience, maybe that's, you know, reality, but I would say even for very small audiences, like the high time is well worth it. Plus you're going to reuse those slides when you have the big audience. So doing it right, no matter the size of the audience, seems quite worth it. How long does it take? I think, you know, if I'm lecturing a new class, I can spend, you know, 8 hours, 12 hours doing a lecture, like creating one. Giving a talk, it's hard to put a finger when you do it in spurts, but, you know, even with some initial content, I think you could spend, you know, 4 to 8 hours just in the slide part, just getting things close to where you want them. Yeah.
Just to provide context, the quote he's referring to is something from our advisor, Devi, and my advisor, who used to say, when you go into a room and you give a 1-hour talk, and if there are 100 people in that room, you are asking them for 100 hours of their time cumulatively. And so you need to put in 100 hours. It doesn't have to be for that one talk. It can be amortized over the period that you've put in. That talk may be something that you deliver multiple times, but that's what you owe to people because you have just asked them for that many hours. So that's the context. All right. Let's thank Kristen again.
I have a quick question as you transition. Was it extra pressure to make this talk when you know you're talking about giving it a good talk?
Of course, yeah. I mean, this is a hard workshop to prepare for because giving advice, you know, it almost implies you know what you're talking about, right? But you don't always, so yeah.
Thanks. All right, our next speaker is Vladlen Koltun. He's a senior principal researcher and the director of the Intelligent Systems Lab at Intel. And I think for me, personally, what stands out about him is that he always tends to have this crystal clear chain of thought that gets described in talks. And I think he does a very good job of crisply describing fairly subtle insights in them. And so I'm excited to hear from him.
Thank you for this wonderful introduction. It's rather daunting to deliver a presentation after Kristen's tutorial on how to give a good talk. Kristen set a high bar that I will try to live up to. So let's begin by considering what business we are in. Research is a collective enterprise. I think of it as a collective adventure towards deeper understanding and greater progress. As a community, we aim to support progress in the broader society. Ultimately, our work aims to improve people's lives and contribute to the progress of humanity. We are an engineering discipline. We build things that are useful. Your work aims to contribute towards building things that are useful and understanding how to build things that are useful. Your goal as an individual researcher is to maximize your contribution towards this community-wide progress. You aim to maximize your utility to this collective process. You aim to be a good member of the research community. The utility that you are maximizing is not the utility of the research community to you. The utility you are maximizing is your utility to the research community. Given that you are going to spend time doing research, you should maximize the value that you provide to the broader process given this time. There are many ways to contribute. Most obviously, you can simply solve a problem that people care about. Do people need to do camera calibration for photogrammetry applications? You could invent the normalized 8-point algorithm. Do people need to estimate robust correspondences for object recognition? You could introduce the CIF descriptors. Sometimes you can contribute tools that are useful more broadly for a class of problems and beyond. So for example, you could introduce graph cuts for optimizing Markov random fields. Originally, those were introduced in the context of image restoration and stereo reconstruction, but they ended up being used more broadly. Or, as in the case of Horn and Shunk, you could introduce a variational formulation for optical flow estimation, which ended up guiding research on optical flow for 3 decades, but also more broadly popularized variational methods in computer vision. You could build an inspiring system that demonstrates that something is possible, that a certain application can now be done, as Dickmans did with autonomous driving in the 80s, or as Snavely, Seitz, and Zelinsky did with phototourism, or as the Microsoft Research Cambridge team did in the case of their amazing work on pose recognition for the Kinect. You could also shift the way the community thinks about the set of problems that are on the table, as Pietro Perana and others did in facilitating the transition from instance-level recognition to category-level recognition, or as David Sellison did in computer graphics by popularizing work on non-photorealistic rendering, or as Rich Zemmel and others did by introducing the problem of semantic segmentation that became one of the core problems studied by the vision community. As you grow older and acquire more experience, there will be other ways for you to contribute. Other ways will open up. One is through service and infrastructure that broadly supports the community's progress. For example, Mikolajczyk and Schmidt conducted a careful, methodical evaluation of local descriptors that established the efficacy of the CIF descriptor and showed to the whole community that the CIF descriptor is indeed effective and facilitated broad adoption of CIF. Or as Jitendra Malik and others at Berkeley did in creating the Berkeley segmentation dataset, a careful, methodically collected data set that shaped research on image segmentation for more than a decade. The Middlebury suite of data sets and benchmarks is another great example, collected by Daniel Scharstein and Rick Zelinsky. Of course, you can also make contributions through open source code that supports the community, as in the case of OpenCV or Café. And sometimes, as you acquire more experience, you will see that your time is best spent in exposition. You can systematize your understanding of a field acquired through hard work and methodical technical contribution. At some point, you will see that you can contribute most effectively by teaching other researchers what you understood through hard work. A good example here is the bundle adjustment tutorial by Triggs and others that systematize the community's understanding of bundle adjustment, or Mike Jordan's tutorials in machine learning. People often ask me, how do I know what to work on? Is an area good? How do I decide what area to go into? I think of it in terms of green pastures. You want to be in an area that's at the right time of its evolution, neither too early nor too late. For some areas, it's too early. The problem is clearly important and would make a great impact, but we lack the basic understanding that is necessary for making a valuable contribution. It is probably not time for you to work on time travel. For many areas, it's too late. The basic framework is in place, the significant contributions have been made, and people are largely cleaning up. They're largely fighting for scraps. Remember the basic principle that you want to maximize your utility. You're going to be working very hard. You're going to be spending a lot of time doing research. Might as well spend it in an area where you can still make significant contributions. Leave it to the other people who haven't attended this talk to do the cleanup. There are many recipes for identifying a specific technical problem that you tackle. I'm going to give you one, but it's by no means representative or exclusive. There are many ways to do this. If in doubt, I'll give you one. Formulate a larger goal that is personally meaningful to you, that will motivate you. This is very important because you will need to work very hard, and there should be something personal that is driving you. I'll give you an example from a researcher who worked in my lab. This researcher told me that they really care about creating technology that helps people who are blind or visually impaired. And this is significant for them because there was somebody like that in their family. And that is why they went into computer vision. So think of a larger goal that is meaningful to you, that will drive you, that will inspire you to work hard. This goal should not be just about you. It should also fit into the scheme of collective progress. It should also be meaningful on the scale of the society. Now break it down into parts, into technical components, specific technical ingredients that need to exist to support this larger goal. For example, you can imagine that a system that supports a person who is blind or visually impaired will be some kind of wearable system with a camera that will guide them as they traverse physical environments and will help them avoid obstacles and will alert them to danger. Well, this requires many things, one of which is estimating the three-dimensional layout of the environment. This means that estimating the three-dimensional layout of the environment is important, and you can now understand exactly why it's important. It's important not just because it's in the book. You see exactly why it's important, and you can also analyze exactly what performance characteristics you need from the solution when the solution is good enough. Then you move on to understanding the state of the art and asking whether this problem that you identified, in this case estimating the three-dimensional layout of the scene, is in the right time of its evolution, whether there are enough nutrients to make a valuable contribution, but still room for making the valuable contribution. How do you make a contribution? First, you do need to read the papers. You need to be reading a lot, and you need to read critically. Don't just buy everything that's written in a paper. You need to look for logical gaps, unwarranted assumptions, and unstated limitations. Ask yourself what the limitations are. When will this break? How could this be done better? Most papers you read were written under deadline pressure and contain some ad hoc decisions that are far from optimal. You want to identify these gaps these unwarranted assumptions, and these ad hoc decisions. To really do this well, you should be re-implementing state-of-the-art techniques. This is one of the best ways to see how you can contribute. Re-implement a state-of-the-art technique and reproduce the results in the literature. This will almost always reveal surprises. You will almost always see phenomena that you didn't expect. Tools will behave in a way that you didn't expect, in a way that's different from what was described in the literature. To begin with, you might have trouble reproducing the results. If you persistently have trouble, this may indicate that there is misalignment between what is stated in the literature and the reality. And there could be your room for contribution. It's to close this gap, to educate the community, and to improve the state of the art. But also, you will see that during this work, during the work on reproducing the results, you will acquire a deeper understanding of the tools. And interesting things will happen when you use the tools. Some will work worse than you expect. Some tools will be taken out of their comfort zone, and you will observe interesting behavior that will inspire ideas. You want to not just reproduce the state of the art, but you want to understand exactly why a system works, exactly what contributes to its performance. You do that through controlled experiments. Take components out, add components in, swap them, replace them. Understand what is important, what really contributes to a system's behavior. This controlled experimentation will inspire ideas and will show you how you can make a contribution. In this process, very often, interesting phenomena will happen that will catch your attention, that you didn't expect. This is important. Many papers that you read are not the papers that the authors set out to write. Many papers are written on interesting phenomena that happened while the authors were working on something else. This is pervasive in science. Quoting Ramon Cajal, she'll happen upon chlorine while trying to isolate manganese. Claude Bernard planned experiments to characterize the destructive agent in sugar, but instead discovered the glycogenic function of the liver, and so on. You need to be open to this. You need to be open to this happening. Remember, the basic principle is that you want to maximize your utility to the community. You want to maximize the contribution that you make. That may not be what you started working on. If you see a more interesting phenomenon, particularly if it involves tools that you are using in your current project and are used more broadly and are not behaving in an optimal way and are not behaving in the way you expected, and you see that you can improve the tools that are useful to a large number of people, you can shift to that and maximize your contribution in that way. At some point, you will make a contribution, and it will be time to report it, to educate the community. And this brings us to publication. The key question that people ask me is quality versus quantity. Junior researchers often ask me whether they should optimize for quality or quantity. And it seems that many people nowadays are daunted by the productivity of some researchers. It seems that some researchers publish 5 to 10 papers a year before they complete their PhD. And people ask whether they should invest more in a single project or publish a larger number of smaller, less significant, more incremental papers. There is absolutely no doubt that you should prioritize quality. There is absolutely no doubt. This follows from the basic principle that you want to maximize your utility to the community. The community will not benefit from 979 CVPR papers turning into 989. Nobody will thank you for adding 10 more papers to the poster floor. Most of those papers just add to the churn. Most of those papers add to the noise without making a commensurate contribution to the signal. The community doesn't need more quantity. The community needs meaningful contributions that meaningfully advance our understanding and our ability to do things. This also implies that there is weaker work that you will end up doing that you need to be willing to simply not publish. Again, many papers actually make a negative contribution by adding to the noise without a commensurate contribution to the signal. Even worse, many papers end up misleading people. Many papers are sloppy. Do not publish papers that make a negative contribution. Publication is not a goal. Contribution is a goal. To counterbalance the seeming pressure for quantity, think of a publication as a liability, not an asset. A publication is a testament to your standards at a given time. A weak publication will be in the annals forever, for the rest of your life, and will be a testament for the rest of your life that at a certain point, these were your standards. If you are like most successful researchers, over time, you will build up a publication portfolio. Most of those publications will be, in retrospect, rather prosaic. If you did your job well, they will make a real contribution to a narrow sliver of the community that is interested in a particular problem or a particular family of problems or a particular family of tools. That is okay. Not all publications need to be glorious. You are not striving for glory. In order to make significant contributions, you need to be doing a lot of work, a lot of research. Some of the most surprising and creative and interesting work arises while working on something else. You are doing something that's fairly prosaic, of fairly narrow interest. It makes a real contribution to a small part of the community. In the process, something interesting happens. You understand some tools deeply. You understand some techniques more deeply. And out of that, creative and significant work arises. To get there, you need to be working. You need to be doing research. And much of that research will result in solid, methodologically rigorous publications of real but fairly narrow interest, and that is okay. Some publications will stand out as particularly creative and significant, and many of these you will not have anticipated ahead of time. You do need to make sure that none of your work is sloppy or methodologically weak. You want to make sure that none of your work misleads the community and guides the community towards dead ends. That doesn't pay. The community will catch on, and your reputation will plateau at a level that will probably not be satisfactory to you. This means, again, that you need to prepare to bury the weak work. It is okay if you set out on a project, nothing particularly interesting happens, you don't really come across findings that are solid, that really stand, that you can really justify. It is okay. It is better to not publish than publish work that's sloppy and misleading. A few words on research over time, and here I'm talking on the scale of years and more. First, there is a saying that research begets research. In order to do good, significant research, you simply get started. You follow some of the recipes I outlined or others, and simply start working on a problem. As you work on a problem, interesting things will happen that will lead to more ideas, more work on related problems, and so on. Just get going. Over time, you can keep track of favorite problems that are meaningful to you and revisit them occasionally. For example, in light of new technical tools that have become available. Problems that couldn't be tackled at some point may be tractable 5 years later. Occasionally go back to the larger goals that drive you and see if you can revisit them, if some of them became more tractable, and if you can revise the list. Perhaps you want to add some goals that became meaningful to you over time, or perhaps in light of technical tools that you have acquired. To stay vital, continue to read a lot, even as you get more senior. I also find it valuable to write down ideas, even ideas that are in my head, because in the process of writing, ideas are expressed differently. It is not the same as thinking. It is also very valuable to talk to people, because in conversation, ideas will be expressed differently, and the interplay between different people will lead to fresh ideas that you wouldn't have had if you were just sitting on an easy chair in front of a fireplace. But do maintain some quiet time by yourself for reading, writing, and thinking. One of the most important points I want to make is that doing good research involves a lot of work. A lot. People often ask me what distinguishes successful researchers from less successful ones, and one key determinant of success is the work ethic. This may be an unpopular point, so I will enlist the help of some predecessors. Henry Ford, I do not believe a person can ever leave their business. They ought to think of it by day and dream of it by night. If they intend to go forward and do anything, the whistle is only a signal to start thinking over the day's work in order to discover how it might be done better. The person who has the largest capacity for work and thought is the person who is bound to succeed. Ramon y Cajal, in science as in the lottery, luck favors those who wager the most. That is, by another analogy, those who are tilling constantly the ground in their garden. Remember Ramon's stories of scientists who discovered interesting phenomena that they didn't set out to discover? The scientist who discovered chlorine while trying to isolate manganese? The key point is that they were in the lab working. They were in the lab conducting experiments. That's when the interesting phenomena happen. You need to be in the lab working. Hamming, successful people exhibit more activity, more energy than most people do. They look more places. They work harder. They think longer than less successful people. Knowledge and ability are much like compound interest. The more you do, the more you can do, and the more opportunities are open for you. I will repeat this. Knowledge and ability are much like compound interest. The more you do, the more you can do, and the more opportunities are open for you. Finally, don't cheat. Give proper credit and support younger researchers who will one day take your place. Thank you.
Thank you. And we already see a hand for questions.
One point that you made was you need to understand why something is working. So my question is, let's say you worked on a project, you came up with a model, and it performs better than existing models, but you don't really understand, and that tends to happen in this deep learning era. So is it okay to put out the paper as a first step so that maybe other people can start thinking about it? Or do you think we should not put it out until we understand it completely?
This should be determined on a case-by-case basis. Sometimes it is okay if the improvement is significant enough. Something you discover, something mysterious, that will take years to properly understand. If you think that this is truly novel, that other people don't know about and will be surprised by and will be inspired by, it is okay to put it out.
It might, can you try again?
So you said many times that you have to read a lot. Sometimes if you read a lot, you get biased by what you're reading, and it might lead to very incremental research. So maybe there's a particular way to read things, or maybe sometimes you don't want to read things. And can you comment on that a little bit?
Yes, so you need to read skeptically. You need to read with an eye towards limitations and an eye towards things that were swept under the rug. But ideas do arise very often while reading. You need to be calibrated as to what the community thinks. It is often possible to continue to make progress without reading. Perhaps you go in a certain direction that's very different from what people are working on, and you just want to keep going. You don't want to get distracted. That can be very valuable, and that's okay. So there are times when you're just going without reading further. That's okay. But you do need to be calibrated as to what the community does know and what the community currently thinks. And it's okay if you disagree with it.
Hi, thanks for your talk. And you mentioned the idea of good citizenship. And I'm seeing a lot of professors going into companies, and recently there's been a lot of discussion about are these technologies used in a good way for societies in general, right? I'm thinking about kind of surveillance, the use that data and so on is used on the internet. Do you have any thoughts on what academics should do, and do we optimize the goal of society or of the research society?
I think this is a great question for the afternoon panel. I don't think I'm uniquely qualified to answer this question.
So I know we're a little behind of schedule, but there's often lots of questions around this. I don't want to completely stifle it.
Hello. I just want to piggyback on that reading questions. So we have so many choice to read these days, like so many papers. So how do we choose? And yeah.
So it helps if you articulate a problem or a direction that's particularly meaningful to you. That can guide your choice of reading. So you can follow some of the recipes I outlined or any others and see if you can identify a problem or a direction that's particularly motivating to you, and then read up on that and around that. If that isn't working out, find a mentor, somebody who you respect, whose taste you trust, who can guide your choice of reading and can help you zero in on a problem.
Hi, thanks for the great talk. I had a quick question on the less interesting research. So you said it's not worth to even publish it at a conference, but I was wondering what you think about putting it on archive to prevent other people to do this research again.
So it depends. It depends what less interesting is referring to. If it's referring to methodologically weak and potentially misleading, you don't want to put it out because that will be a drain on the community's resources. That will be a negative contribution. Again, nobody is asking for more archive papers on cs.cv. If it refers to negative results can be interesting. If it refers to small, neat, practical tricks that can help people in their practice, that can be interesting. And there are forums for that, like blog posts or archive papers.
Hi, thank you. So you had 3 slides on working hard, and it seemed to be almost an extreme point of view, right? I just wanted to push back a little bit on that. And so my mother, a PhD in biochemistry, she burned out and retired early at 50. And I just wanted to hear, you know, this is a very fast-moving field, and don't you worry that people are going to burn out if they just work all the time?
Yes. So I knew that this will be an unpopular point. Burnout is actually a separate phenomenon that's interesting that I didn't address. It is important that your work is tied to your personal motivation, something that is personally meaningful to you. The way to sustain hard work for many years and decades is to see meaning in your work. It shouldn't be just a 9 to 5. If it's a 9 to 5 and it requires great sacrifices, if it's just a job and you need to sacrifice a lot of your leisure time for it, that is not sustainable. What I'm describing here and what these predecessors that I quoted from were alluding to is a regime in which work is so meaningful to you that you want to do it, that it grips you in the evenings and in the weekends. You think of it outside of the office. It is so meaningful that you want to invest great energy in it.
All right, I think we should stop the questions for now, but please do come back for the panel and we can keep a lot of this going. I'm sure there are sort of both sides of arguments that are fairly valid on a lot of these dimensions, so we should definitely do that. All right, our next speaker is Adriana Kavaja. She's an assistant professor at the University of Pittsburgh. And I think one thing that I'm particularly fascinated by about Adriana is that she has this knack of picking these really creative and interesting problems, especially in a lot of her recent work. And then she finds ways of systematically breaking it down and sort of addressing them and making progress on those. And so we're looking forward to hearing from her.
Thanks, Devi, for the introduction and for organizing this workshop. So what you said, well, I wish that was true, is not entirely true. I don't always know how to break it down, and that's something I'm trying to figure out. But yes, that's the hope. So my title is really vague because I wanted to mention kind of a few things that I thought kind of would be possibly interesting. So when I say research in context, what do I mean? So we do research in trying to understand images automatically. So there's, you know, you can name many types of contexts. So one thing I'm interested in is where people usually see these images that we try to analyze. For people who are not researchers like us, that might be the media. So I'll talk about how I investigate that. I think it's also interesting who cares about this research. I think that's many, many people nowadays. But I'm looking at kind of the impact of images on society, a certain angle of that, specifically persuasive images. And because it's a very interesting field, I think we could be doing a good job at outreach and education of people, kind of using that momentum that we have to educate people about computer science and about a whole bunch of other things, which I'm not doing that well, but there's plenty of other people who are doing very interesting work in that. And then there's who does this research. So that's usually graduate students, but there's also undergraduate, and I'll talk a little bit about my experience with that. And I think it's also important to foster and mentor students, and not just students. So what Devi was referring to is this work that I've been doing recently. So the idea is that images don't just live in our data sets. They can kind of be active participants and cause change. Not all images do that. Very few images do that, which makes the problem challenging. But there's lots of iconic images in our, what I call media consciousness, I don't know if that's really a term, of images that have changed certain things. So images have changed kind of the public perception of AIDS, have caused people to stop smoking, have caused presidents to admit refugees based on seeing the poor conditions that they live in. They have, images affect, there's work from people that I will name later, but there's work in showing that images actually cause election results to be one way or another. Just the face of a person can be persuasive. This is an iconic image where the author described it as, so this is actually showing a person being killed. That's kind of an iconic image from the 60s, but the author said, who received a lot of awards, said that I killed the general with my camera because the way this photo was perceived totally destroyed this so it's this general here on the left. So this was perceived as being extremely cruel and kind of changed the course of the Vietnam War, supposedly, but this photograph totally destroyed this person's life, basically, because it shows them doing something which maybe they shouldn't be doing or maybe they should be doing. So the way this lived in the media really changed this person's life. What I work on is advertisements, and so plenty of ads are bad, but there's also plenty of ads that are good and that actually have an impact. So these are just some examples. So ads can be product ads, which is what all my visual examples actually are, but they can also be what I call public service announcements. So there can be anti-smoking ads. So these are just some examples of campaigns that really had a huge impact. And so this is interesting, I think, because it requires novel techniques. So we have these images that are trying to make a point. So different people would perceive this differently, but it's something about the environment and trees being our lungs and something bad happening to the tree. So this is a lot of kind of visual, kind of atypical visual processing and also reasoning coupled together, which makes it hard. But to understand how this might affect people, how it might make them want to protect the environment is, I think, important. What I meant to mention was, if you think of how you see images of politicians in the news and maybe they make you laugh because you already don't like that politician, we've done a great job at understanding who that is and maybe what surrounding they're in, but we haven't really understood, why that makes you laugh and how that might affect your voting behavior and how that might affect the lives of other people. So I'm not quite going there, but that's what I meant by images being important. So we do actually look at political advertisements. These are just some other examples. So this is a challenging problem. That's not really what I want to talk about here, but we have a data set to tackle this problem that's obviously publicly available. So I think that's one good thing to do if you have a data set, put it out. I think I don't really need to say that because people usually do publish their data sets. And to show you why, so this is just trying to convince you that you should help us out with this problem because it's important to understand how images affect people's choices. So I picked this because I know some people like this image. So if you look at existing state-of-the-art systems and what they output, even a captioning system, it's pretty good actually. A man standing in front of a display of food, it's pretty correct. But it's kind of not trying to get the point of the ad in terms of persuasion, so it's not getting it. So we might say, what a human might say, it is that food at Burger King must be really good since even this McDonald's employee is secretly buying it. And there's others working on this problem. So some of them are giving, one already did, one will give a talk in my workshop, which is just a few rooms down. And I hope there's more people trying to work on this. So this is, what I do is not exactly computer vision with a cause or for social good, but there are other people working on that. So there was a spotlight, I think, on Wednesday on question answering for people who are actually blind. So this helps put VQA in a different context. So this is what I wanted to talk about on the research end. I think this is still kind of related. So one thing I've done that I think is good, I mean, I've mostly done it to build my resume, right, because I'm selfish, but I think it's also good for the community, and it's actually not that much effort in some cases. So organizing workshops, I think, is good for the community. It helps you, meet researchers who are working on related problems, helps you network, helps you learn about work that you may not otherwise learn about in case that work is not exactly mainstream. So if you're a student and your advisor doesn't mind you doing that, or you don't have to be a student, I think it's organizing a workshop is a great thing to do, and it's great fun. So this is kind of education within our community. I think we should also be doing outreach beyond the community. So I was involved 1 year in this Women in Computer Vision workshop, and it's now in its 3rd or 4th iteration. So that's still kind of on the border of our community, but it attracts women who may not otherwise make it to CVPR, who are really interesting and have a lot to contribute. So Olga and Feifei have this AI for All Foundation, which I'm in no means involved with, but I think that's a great, so they try to educate, I think, middle school, kind of underrepresented groups, and I think that's gaining momentum. It already has a lot of momentum. And there's kind of local initiatives at different universities that are similar to that, that I think are, so I think our field is so interesting because we have pictures, right? So people are attracted to that, that we can use that to educate them about more boring concepts, and I think we should be doing that more. So another thing I've been involved with that I think is a great idea, it wasn't my idea, I just kind of volunteered to continue it, is this doctoral consortium, which probably a lot of you know about. So this is a mentoring event for senior PhD students, which involve lunch and one-on-one meetings between mentors in academia or industry and their mentees, and then I did a panel discussion. I don't know if other ones have done it. So this is supported by NSF and industry. So I think this is great, really valuable to PhD students who may not have a lot of people that can advise them on kind of sensitive issues. Maybe you get along with your advisor, maybe you don't. And so I think this is a great opportunity for outside opinions. In fact, I think we should, I mentioned mentoring women, I mentioned mentoring senior students. This is, in a sense, a mentoring event, and I think it's a wonderful idea. I wonder if we should have more mentoring events, say again, selfishly for, say, young faculty or for young researchers in industry. So also, along the lines of mentoring and fostering students, this is totally unrelated. I had a lot of different things to say that were not related. But so I think a lot of you are already working with undergraduates, but if you're not, give it a try. So my first experience was terrible, and I was really mad, and I decided to never do it again, based on one data point. So then I had a baby, and I had some time to think of concrete projects that I could give to less experienced researchers. And so I agreed to work with too many undergraduates, but they all turned out to be great. In fact, I was amazed at how productive they were, and how, sometimes my grad students complain about doing stuff more than my undergraduates were. So the undergraduates seem really driven. So we have some papers that are currently under review, and I think that's great to publish with undergraduates. It's really refreshing to work with undergraduates who just want to do things. When I started in academia, I didn't really think I would enjoy teaching, and so I'm aware there's a lot of text here, kind of on purpose, but so I had kind of a hard time connecting with students who are not kind of the best students, who the best students don't really, I think, need you to teach them. They already know what they know, or they can just read up on whatever they want to learn. So it was, it was the less good students that I needed to connect with. And at first, the first time I taught undergraduate computer vision, I wasn't really able to do that. Of course, it was partly my experience, partly I was getting really annoyed by kind of questions that I thought were silly or that I had already answered a million times. The third time, again, it had to do probably with having a baby and becoming more patient. I decided that I wasn't gonna get angry at people because they only have so much bandwidth to pay attention to what I say in class. They have so many other classes that I need to take. So I kind of started I decided that I'm just gonna assume they're right to ask that question. And I'm just gonna treat them, I always treated them as equals and reasonable people, but some things upset me that shouldn't have upset me. So what happened is that I think I also became more informal in class, which is good and bad. But the third time I taught the class, it was really fun. There was laughing in every class. The students seemed really interested. I think that's not it's by no means an accomplishment because our field is just so exciting that students are just excited because they're taking computer vision. But it was really great to see that excitement. And graduate students are, of course, also excited, but undergrads, being that they're younger, it's kind of it's a little bit different. And the interesting thing that happened is that I didn't have many kind of complaints from students about this is a lot of work, or this is why did you grade it in the way that you graded it. So basically, because I trusted that they were reasonable and always assumed they were right, they actually were right and reasonable most of the time. I cannot really think of a case when someone was being unreasonable. So in a sense, the fact that I was treating them in this way meant that they treated me well too. So my goodwill kind of bred more goodwill on their end, which was an interesting discovery for me. So it made my life actually easier. And then there's the fact that undergrads not knowing as much about computer vision as graduate students might know, they have interesting perspective. I think that's not surprising. So I think it's really hard to say what it means to be a good citizen of CVPR. That's why we have so many people saying different things. But my kind of, what I've learned so far in my experience is that it's important to think about why our research matters and its impact on society. It's good to share our data sets as a way to involve others in what we do and get better, results. It's good to reach out to groups outside of the community whose involvement we can benefit from. It's important to foster graduate and undergraduate students and provide all the mentoring that we can provide them. And again, if you haven't tried working with undergrads, do give it a try. So, thanks. Questions?
Thank you, Adriana. Do we have any questions? People are hungry.
Yeah, let's just go eat.
All right, so again, at the end of the day,
I think I
there
see
is a
one.
question.
Hi, Adriana. I wanted to ask you, as I've been working with a couple of undergrads, so how to establish a better relationship with your fellow undergrad students and bridge that age gap and have be on the same level as them, and you have to really nurture them right from the beginning. So how do you do that?
So that's the part that I don't know. I think I got lucky in that so given how popular the field is, I can afford to just pick the best students, right? They're not trained in computer vision necessarily, but they're very, very driven and have good technical background and so on. So I guess you can assume that that's going to be true, but you still have to, train them, and that takes time. I actually don't think I'm that, great at that. So training students takes a lot of time and a lot of hand-holding, and that's something you should be willing to invest in. It's somehow, I sometimes forget how much work that is and how much it actually needs to be done. Otherwise, you and the student end up being unhappy. But that's actually the thing that I'm least confident about that I can do. So I don't have a good answer, but maybe someone in the panel will. I'm sure someone will.
Hi, thanks for the good talk. You mentioned that you were able to get some different perspectives from undergrads. So in that context, what do you think graduate students can learn from undergrads?
So what I meant is, even when this comment came out of two things. So one, I had a student who was kind of falling behind in my class and wasn't doing very well, and I asked her to read some, so she wanted to do extra credit, and I asked her to read some papers, and then we met in office hours, and I told her I would ask her some kind of questions about the papers. And some answers which kind of we would think as being foolish actually were interesting that she had to say. I also asked the last assignment for my undergrad class, I ran out of time in designing it, so I thought I would do something simple, which is that I asked undergrads to try out some available Vision-y demos that are out there, and to say what they thought vision systems currently did well and not well. And the things they had to say were, so they all were saying that we should be recognizing more specific things like particular people, so that's obviously a function of what demo I had them use. But if grad students so that could help us kind of focus our research in a sense, if we think of the students as being consumers, if we think that consumers are what matters. I'm not saying that's true. But I don't know, undergrads are less biased in terms of, we know the flaws of vision systems, what they can or cannot do, but undergrads don't, so it may be refreshing to have kind of an outside perspective. So I think it's more that maybe people who are more senior should every now and then look at what the average person thinks of our work. I don't know if grad students need to do that, because they need to focus on something in particular, but it's kind of what I meant with that.
All right, let's take a question.
Oh.
Okay.
This is probably something that I could ask you in person, but maybe it will benefit people too. All right. Maybe it'll benefit some others if I ask the question in public. So it seems that as a junior faculty, you might be also a little bit more well-equipped to answer this, because it seems like there is this tenure track rat race that all junior faculty kind of feel the pressure of having to publish and so on. So do you feel like there are potentially better incentives that can be set up at an institutional level to help junior faculty sort of actually feel like they should be working on sort of being a good citizen rather than just worrying about, passing through all the hoops for tenure and so on?
Right. So I think even though sometimes like the review system is not great and publication is, not maybe what it should be, I think whether you have publications or not is a pretty good way to judge whether your work is good. But I think for people who are decent researchers but say want to help the community out more than others, I think maybe there should be incentives, and I think some departments, some higher ups in my department say that, counts don't matter. We want to encourage products, which by which they don't mean actual products. They mean, say, data sets and how many people care about your data set and are working on your problem. But I don't know, I agree there should be other incentives. I just don't want that to take away from doing good work, I guess, in your research field. But maybe there can be people research faculty who focus more on one thing versus others.
Maybe I think this is also something that we could talk about more at the panel, because not just for junior faculty, even grad students, they have to get a job at the end of it. And sort of trade-offs like that, I think, lead to interesting questions along these things. All right, so with that, let's wrap it up for lunch, and we'll meet back here at 1:30.